Hello, hello world, hello internet. Happy Monday. Welcome to Coded Live, folks. Welcome to our user group meeting. If you join us for some of the other streams we do throughout the week, this is a little different. This is a little more formal. It's a user group meetup that we used to have in person, but hey, we're all living through a pandemic, so we're at least glad to be hanging out on the internet. So I'm your host, Sam Basu, and with me, I have my good friend, Shawn Wildermuth. How are you, sir?
I'm good. I hope everyone out there is staying safe and sitting safely behind their monitor with gloves on and a mask on.
Yeah, well, yeah. So we are. There's light at the end of the tunnel. We are hopefully slowly coming out of this.
It feels like it.
Yeah. But yeah, good afternoon, good evening, wherever you might be. Thank you for joining us. I'm going to spend maybe just a couple of minutes up front with some housekeeping. So a big welcome to the folks who are normally joining us for our user groups and everybody else who might be just hanging out with us online. So welcome. This is the active user group. We started out of Columbus, and we've been going strong for actually 10 years now almost. So you can find us online, user group website, Meetup, Twitter, and we meet right here, third Mondays. Well, actually, today we are meeting a little earlier than normal. We normally start around 5, but today we are a little ahead. And hopefully someday we are going to get back to in-person events, which is at Improving Ohio in Columbus. So here are some of the folks who have always supported our user group. We can't do physical swag yet, but again, hopefully someday. But we are still glad to be able to just get together and hang out. So few events that we always try to kind of highlight. If you are in the Midwest, in the US, some events to kind of go to, regional events. Many of them are completely online. Some of them are hybrid. Some of them are in person. So I just want to highlight some of the things that are coming up. So this is the .NET user group. That's also in Columbus. This is our sister user group. I am not sure about July. Maybe they're skipping a month because I didn't see any July announcement. But looks like August they're back on. They meet the 4th Thursday. Some months it ends up being the same week as us. And looks like they're talking about .NET MAUI and .NET 6, which is kind of in my ballpark. So I'm curious to see what the speaker has to say next month. Moving on to some events that are actually opening up, especially stateside, and some things in Europe are also opening up. So that conference, this is one of my favorite conferences to go to. This is in Wisconsin Dells in a giant water park, and that's actually happening later this week? No, next week, early next week, right? So again, if you are close by, if you don't mind a drive maybe or hopping on a short flight, they got a great lineup of speakers. A lot of them, this is the first in-person event that a lot of people are going to. So definitely check that out. We have Codepalooza coming up. This is in Louisville, Kentucky. This is Chad Green and the folks. This is coming up in actually less than a month now. And this is all online. So we are just going to all do our thing from our homes. But at least, hey, it's a big lineup of speakers, good content all through. Then we have KCDC. Just before we hopped on or we went live, Shawn and me were just talking like this is the first time we're going to actually see each other after a long time. This is in Kansas City, which is not in Kansas. It's in Missouri, and that's coming up. It's coming up in September, and we're excited for that. Again, one workshop, I think, like 3 days of content, so should be a lot of fun. They just announced speakers, and they should be updating their site with their schedule. And this is all in person, so again, use your judgment. If you feel confident and safe, please come and join us. I think you're going to see Shawn and me there as well. This is Tech Bash, kind of another Kalahari conference at a water park. This is happening in October, also in person. This is on the kind of the east side of, well, about an hour west of New York City in the Pocono areas in Pennsylvania. So great lineup of speakers already. They have started announcing, again, 3 to 4 days of great content. So yeah, lots of things to choose from if you wanted to get back into developer events. And we actually partner with the VS Live folks. This is a company that puts together lots of different shows throughout the year, but they haven't been doing in-person shows yet until this November is their first like big in-person show that's coming up. And this is in Orlando, right in the middle of the resort kind of atmosphere. 5 days of content. They're combining like 5 different conferences into one. So this could be like your big family outing as well if you want to take the family along, or just bring your team. So if you do go, you get a big discount from being a part of this user group. All right, so next month, we actually have our good friend Khalid Abu Hapme. He's going to talk about, well, he gave me a lot of options like Vue and other things, but he said, like, why don't we get kind of off topic a little bit? We always talk about tech. How about blogging, which is something hopefully a lot of us are into. How do you make a name for yourselves? What are some of the platforms? What are some of the gotchas? What are some things you do to be successful? So I'm excited actually to have Khalid on next month. And this month we have Shawn. Shawn is, well, he doesn't need any introduction. So he's a movie maker. Well, that I will give you. That's rare amongst us in the software industry. But Shawn has been doing what we do for how many years, Shawn? Like 20 years now?
35.
Oh boy.
I'm older than I look.
Well, I thought I'm old at about 20, but yeah, you're way out there. But Shawn has dozens of courses on Pluralsight, like the web and APIs. This is what you live and breathe. And you're here to talk about actually something a little different, gRPC, which is RPC calls across any framework, any platform. So I'm excited. So with that, I'm going to give you the floor so you can take it away.
Great. And I assume everyone can see my slides now?
Right now, yes.
Awesome. Well, I'm excited to be here. Again, my name is Shawn Wildermuth. If you don't know who I am, I have a blog at wildermuth.com, and I'll just do the very brief repeat what was already said. I'm a Pluralsight author. You can go see a bunch of my courses there. I also have a movie out called Hello World, film about software development and inclusion, and love you to take a look at that as well. And we'll dive into the actual work. So I wanted to talk about gRPC, but before we can, we need to sort of look back, because we've had this notion of distributed APIs for a long time. You notice this time span goes back to the 70s, because the idea of distributed computing really came to being, before some of us or most of us were born. It's actually after I was born, so I apologize. And that really came in 3 forms: RPC, which is remote procedure call, messaging systems, and queuing systems. So if you just started getting into using queues and messages, and it feels like the new shiny thing, it's not. The idea of it goes back so long. In fact, predates things like relational databases in some cases. And so these systems, distributed systems, needed to talk to each other in some way, and they had a couple of ways to do it, and things were okay. And then object-oriented API started to come around, and we started to see COM, DCOM, Corba, Java and RMI as ways to sort of try to pretend that we didn't have distributed APIs, that everything felt locally but was remote. And I think as an industry, we sort of figured out that was not a terribly good idea. It was too easy to create APIs that were inefficient or terribly inefficient across machines. But we also came into this problem of needing to think about how we were distributing these computing units. Like, did these computing units go across the internet? The internet started to become a way we wanted to communicate, and these didn't do terribly well over internet connections, mostly because of things like firewalls and proxies. And so web-based APIs became sort of the norm as you were building distributed systems, even just websites. A lot of these early projects took advantage of XML HTTP in the browser to start communicating with backend servers and having the servers call them. And because normally port 80 and port 443 for standard web stuff was allowed, it became easy to sort of hop on the back of what the web was already doing. And that introduced REST and SOAP as two very common ways of building these ways of communications. And they were both built on different sort of ideals about how you would communicate across web APIs, but they both have their uses and their detriments, just like any of these in this list. And then much more recently, you may have touched GraphQL, and then we're going to talk about gRPC, which is one of the newer contenders here, to kind of understand and get around some of the limitations of things like REST. Hey,
Shawn, before we move on, that was actually a great slide, and folks are appreciating some of the things you're mentioning here. So I'm going to pull up some of our friends here. Curious Drive is here. Hello. History lessons, and who better to give us history lessons than Shawn? So thank you for that, Shawn. Our some of the regular folks in our user group, Conrad is here. Conrad, yes, I fat fingered. I mentioned August. That's actually the next month. Khalid will be on for August. And speaking of Codepalooza and another veteran, here's Taylor Learn Code. Mr. Chad Green is here. Can Shawn do gRPC 5 times in a row? We shall see. Shawn is just getting into gRPC. And Fool Schnabel is here. And DDX on Windows? What is that? Do you know, Shawn?
DDX on Windows?
That was based on IIRC. I have not heard of that.
No, neither have I.
Okay, well, Full Schnabel, keep educating us. If you have a link or something you can drop so we can all maybe learn more.
Yeah,
so things have come a long way, like starting from the 70s to now. So let's have you get into gRPC. Like, what is it that we're trying to solve, and why do you like it?
Sure. So a little bit about gRPC. The idea behind it is straight from their website. So, of course, take this with a grain of salt. A high-performance, open-source, universal remote procedure call framework. And what does that really mean? So when we look at gRPC, let's start with that acronym, right? And directly from the website, it says gRPC is, the G stands for gRPC? Yes. They are being very meta about it, because I think the G really stands for Google, where it was developed. And so sort of understanding of where this came from, I think, is going to be important. But unlike APIs, this really is more about sending messages back and forth. When we think about APIs, in the way we do things like in REST, for example, we are doing this message-based communication. So what does that all mean? So gRPC uses a binary communication. It's not XML. It's not JSON. It is a binary communication. It is contract-based. And so if you've done WCF, you're probably much more comfortable and familiar with contract-based instead of convention-based, which is sort of the way that REST works. REST says, okay, you send me a request, and hopefully it'll be formatted in a way I expect it, and then I'm going to send it back. These are agreements ahead of time of what these APIs look like. It is available across all ecosystems. And this idea of secure by default, in that gRPC simply doesn't work over HTTP. There's a couple of small exceptions there, but for the most part, it doesn't work over HTTP. And the reason it doesn't is it's reliant on HTTP 3. And HTTP 3 is only secured. Like, there's no such thing as using HTTP 3 without it being secured. Another key important idea here is that it supports unidirectional and bidirectional streaming. This is something that is much more difficult, and there's a lot of sort of workarounds to make this work. Projects like SignalR are there to sort of fit into that as well. And we'll talk about where this fits across SignalR, REST, and other things in a minute.
Hey, Shawn.
Yeah.
Before you move on, sorry, I forgot to tell you, like, I'm your kind of annoying sidekick who just keeps on asking dumb questions.
No, it's fine. Please.
Okay. So when you say contract based, like, is that something to be kind of maybe a little cautious about? Because like WCF did not end well for a few reasons.
Well, it's interesting because it depends on what you're building. So WCF actually was incredibly well successful in the places where it was important to be successful. And so that's going to be part of the story with gRPC, is that I think us thinking about one kind of API is going to be an archaic way of thinking about it. So things like GraphQL do certain things incredibly well and do other things less well. gRPC is going to be the same way. REST is the same way. And so finding where in your ecosystem you want to have different ways of communicating, I think, is going to be key. In fact, I think that's where we go with the next slide. So with something like REST, CRUD and purely web apps work really well. You know, it's a tried and true technology. We're comfortable with it, and it's really matched to those sorts of situations. And then we have, whoops, how did I get way back there? There we go. And something like SignalR is really good at multicasting and doing web messaging. In fact, that Blazor uses a lot of SignalR to have that sort of like tight coupled messaging in there. And SignalR, especially for multicasting, I want to be able to take a server and broadcast to a bunch of machines some information. SignalR is incredibly good at that. Something like GraphQL is great for open querying and reporting, where you don't know the nature of the request before it's written. And so, you know, setting up GraphQL isn't a simple process, but you get a lot of power in that the clients can be responsible for the kind of API calls they want to do. You're not sort of limited. In some ways, it's the opposite of gRPC, which is we want strong contracts. We want versioned contracts. We want to be able to support streaming of data. We want to deal with low resource clients, and in many ways, inter-data center communication, where we don't need to have that loose, what's the word I'm looking for? We don't need to deal with the same security requirements, that we want to be able to just know that both sides know exactly what the messages look like. And because we're dealing with low resource clients in an inter-data center, speed also becomes important. So wanting a format which gRPC supports of a binary communication that is easily serialized and deserialized becomes crucial. And I think when we see it working before we get through the once we get through the slides, you'll get a better sense of what that means.
All right, Shawn, two quick questions.
Yeah.
Full Schnabel was asking, this is RPC we're talking about, right? Like, what makes gRPC better than the existing ones that are out there?
Mostly because there is it operates over over web ports. It's reliant on HTTPS. So you can think of it as RPC for anything that can connect to internet clients, that can do and handle things like proxies and caching servers and streaming. So it's not better. It's more of a trying to be a universal one that isn't matched or required to any specific language. The language we're going to be talking about that we define these contracts is not specific at all to any specific language. In my course, I actually show a Python system communicating with a .NET backend, and it could be C++, it could be Rust, it could be anything. And so it gives us more of that benefit we're getting from REST, where we don't care what the clients are, but allowing us to have strong contracts. And there are cases where that's really important.
Nice. Yeah. And
Other
then
questions?
one more
Yeah.
from me. So when you talk about like the streaming part of it, which is kind of what SignalR does as well. So gRPC can do real time. Is that correct?
Yes.
But
Yes.
okay. But it's not meant
Real-time.
for just that.
No, it's one of the features in the bidirectionality. So SignalR and gRPC are different in one key respect. SignalR can do streaming, but gRPC does not do multicasting. So it's not it's meant for a client to server communication, and what you're getting out of that is speed and ease. So low resource clients like IOC is a great example. In fact, I think that's where we go in a couple of slides to show you sort of in a typical ecosystem where I would see gRPC being beneficial. So I'll get there in just a second. An important question is, does this mean I don't want you to use REST anymore, or I don't want you to use whatever technology? And, the real answer is absolutely not. Like, this is an addendum. This isn't a replacement. And that's really important to me because I've become suspicious in the 35 years I've been in this with anyone saying, X is dead and everyone should use Y, whatever the technology. Because, software to me is is all about compromise, and finding the compromise that fits your domain is our job as developers, right? We're trying to find the right tool for us. And that doesn't mean that we have to go, oh, I'm not cool enough because I'm not using React versus Angular, or I'm not using REST versus GraphQL. If we get caught up in that sort of the hype of a technology not having any flaws, or more to the point, having to figure out where if it fits best with our technology, I think we're failing. We're getting caught up in marketing, not in the real technological benefits of a particular project. And so let's talk a little bit about how it works before I dive into where it works best. Any questions before we go on?
No, but
Right.
Shawn, folks like that you have a slide that just says no. That's awesome. And I think we're going to get into this, and this may be a loaded question, but Credit84 is asking if it's worth using gRPC with Node.js, which I don't know if you're going to get into it.
I'll talk a little bit about.
Yeah.
It does work with Node.js as well, though because it's JavaScript, there are some performance implications there, and I will explain a little bit about that. There's also another project about using it from websites as well, and I do cover that in a minute.
Okay.
So gRPC is tied to HTTP 2 and 3 in that your servers must support it. And so one of the things is most browsers don't support this yet. I think this slide should see HTTP 3, not 2, because most browsers support HTTP 2 now. So my apologies. This new protocol, or this maturation of the protocol, is something that gRPC relies on to enable them to do this sort of connection, allowing them to have a connection between a client and a server through a web server. The format is ordinal and binary, so it's much harder for JavaScript to parse, which is one of the reasons why there's some limitations into how Node can work with it. So though WebAssembly is a good way to get around that, there's some libraries out there that are using WebAssembly to efficiently parse the messages, and that contracts are required. And this isn't always great for things like websites. So that's not really where gRPC sort of fits in. So there is a gRPC web. I'm not going to talk a lot about it, but it's sort of a proxy on top of gRPC to make the calls more friendly to JavaScript. But you're losing some of the benefits in that because you're converting binary into a non-binary format, there is some decrease in the performance of it. Now, that performance is likely to be as fast as REST because that's the same thing REST does. So if contracts are important to you and you think that's a good match for your organization, gRPC Web is something I'd look at, but it's not really the use cases I'm going to be talking about in this talk. So finally, where does it belong? So I have some web service out there. I've been calling it from some browser, and I've been using REST for a while, and I don't think that should change necessarily. gRPC doesn't really belong there, but where I end up using it is to communicate within the data center quite a lot. You can also use gRPC to communicate with mobile clients as well, though if I've already got a REST interface for a web interface, I typically would use the same thing with the mobile clients as well. And so you can see that because you have tight coupling in some ways inside the data center, you own and know both sides of it, those contracts actually benefit you instead of it being a detriment. A way that when you build the API and the other services, you can use that contract to know exactly what the APIs look like. And again, this will make a little bit more sense when we get into what the code looks like in just a couple minutes. I don't like slides, but gRPC is different enough that I think it's helpful. One of the biggest situations where gRPC really benefits is in Internet of Things. And that's because Internet of Things are often resource limited. And gRPC works really well on lower powered devices simply because the serialization and the message size is so much smaller and faster. And you can use gRPC to partners. It's less common than something like REST, but you certainly could use it in those scenarios as well if you need those hard contracts. And this is where WCF has done really well in the long term, is allowing organizations to have hard contracts with partners as well. And so this might be a place. So if you're coming to, let's say, .NET Core from ASP.NET, where you've used a lot of WCF, gRPC also represents a comfort in the kinds of development that you're used to doing, especially with contract-based. Questions about that before I dig in? Because that's usually a big question.
Well,
slide.
Maybe not on gRPC itself, but Conrad is asking, where are things with HTTP 3? Like, do you know any browsers supporting this yet? Or is that a bottleneck?
I don't think it is, because as you can see here, the only place we're really using the browser is in calls directly to clients. So most servers now support it, and in fact, if you look at the way that gRPC is used in these scenarios, there isn't a browser involved in anything but the upper left-hand REST call. So I don't think it is actually a barrier. I don't actually think gRPC is a great solution for browser to server communication anyway. So the limitation of the browser starting to catch up with it doesn't bother me much. But I could see why you would be concerned. They'll certainly get there, but we all know browsers, drag their feet, and they'll all, even when Chrome supports it, will, the 34 other places support it. Will Android browsers running, Android 4 that still exists out there support it? Of course not. And so, a bit of browser support is always about least common denominator anyway. And HTTP 3 is a big hurdle. You can't just shim in HTTP 3 into your JavaScript code.
Yeah. And Chad is pointing at caniuse.com, HTTP 3, to kind of tell you where things are.
Can you use .com? Is that what you said?
Caniuse.com.
What do you mean .com?
No, it's a site, so that tells you where things are with support. Yeah. They tell you the support there. Yes. What I can use.com. Yes, I got confused there for a second. And while we're talking, we'll let you move forward. But our good friend C# Fritz, Mr. Mr. Fritz, he subscribed at tier 1. Thank you very much. All right, Shawn, go ahead, please.
So the contracts, the interesting part of this is in some ways sort of a throwback, but the contracts are defined using an interface definition language. This is one of the reasons why it's so language independent, is the actual contract isn't a C# file or a C file or a C++ header file. It is this language that you're going to define what it looks like, and that's going to be translated into those specific languages. In fact, what happens is the contracts are run through a generator that then generate the boilerplate that is the beginning point of those contracts based on the language. And so it defines both server and client code for those specific languages. So if I define in let's say in a .NET Core or .NET 5 project my contract, and then someone's going to point at this what's called a protobuf file or a proto file. When they want to consume it, let's say in Go, they're going to get something that knows how to communicate with it because that contract is guaranteeing what that looks like. We don't have to deal with Go needing to know about my data types. Those data types are defined in the protobuf language, and I promise you'll see this in a minute. Speaking of protobuf, this is that language that we're using, and it's not actually written or specific to gRPC. It predates gRPC. It's used in a number of situations when they need an interface definition language. gRPC has adopted it as the one that they're going to use, and it's, again, language and platform neutral. You can extend it to define your own types, which you'll see that the core types are kind of small, and then everything else is extended from that. And then more importantly, that it's the language tells you about how it needs to be serialized or deserialized, and that's the big key component here of using a language to define your contract. When we're talking about encoding and decoding, which is only part of the speed issue, but it is an issue when you're talking about this, we can see that protobuf is enormously fast comparing with JSON and JSON streams. Now, when we're talking about like within the data center, I'm not sure the speed matters a ton, but when we're talking about things like IoT devices or resource limited devices that are out there, this becomes really, really big because the payloads are smaller and the speed of encoding is much, much faster. And so those get into those situations where it just makes more sense to use something that's going to be more efficient. I'm usually against a premature optimization. This is a case where we know that we're going to be dealing with smaller compute surfaces, and this is going to allow us to sort of deal with it.
Shawn, do you know who started protobuf? Is it a Google thing, or has it always been like an open standard?
I believe it is also a Google thing,
yeah,
if I remember right. But I'd have to go look.
Yeah, and this really matters because I haven't done enough gRPC, but I tinker enough with SignalR to realize the cost of that JSON serialization, deserialization. Like they use something called message pack if you wanted to, but like going down to the binary really cuts down on the size of the packages and as well as the encoding and decoding. Yeah.
So let's jump into a demo so that hopefully some of these things will start to feel real. And so the way you start this, I'm going to switch over. My fingers will work to a project I have. The project has two pieces. I have a .NET 5 web server that doesn't have gRPC involved in it at all. It's just another web project, though there are templates for building gRPC projects. But I want you to see sort of how the pieces move. And then I have just a console app that's going to consume it, just so we can have sort of two pieces so we can see how that works. So if we, can everyone see the size of my screen at all? The code will be bigger.
Yeah, I can see it. Yeah, as long as you magnify the code a little bit.
Yeah, the code will be fun. So if we add a new item to our project, one of the options, I'm going to use search here just to, because it's so big. Whoops. Is a protocol buffer file. And you see it has the extension of .proto, and I'm going to call it weather.proto. And we can see this is just a simple text file, and it starts out by saying which version of protobuf we're using. And gRPC all uses protobuffer 3. So if you look at the docs, that's going to be important. And then there's an option here that's specific to C#, and there are ways to set options for different languages. In this case, I'm just telling it what namespace I want to be in, and I'm going to call this the weather station. I hope I remember everything I'm doing. And that just, when it generates the code, it will generate it in a specific namespace for us. And this could have, obviously a hierarchy in it. I'm also going to create a folder for proto files and just move it in there because I'm a control freak. If you haven't seen me talk live, it's important. And so we have this proto file, and let's write the definition language, and then we'll get into how we're going to actually use it. And first, what it does is it allows you to define a service. And the service I'm going to call our weather service. And you define what those calls in the weather service are. And so it starts with RPC, saying this is going to be an RPC endpoint. And we're going to call it get weather, because how easy is that? And then here we're going to want a parameters into the weather service, and then we're going to want to say what it returns. So again, this is a communication back and forth, and it may not be bidirectional. You may just be sending it with nothing in return, but this is the basic syntax of what it wants. And what can we send in return? We're going to send messages. And so I'll call this a weather request. If I can spell request, it returns you guessed it, a weather response. Now you can call these whatever you want. Now, you'll notice these didn't get highlighted because it doesn't know what these are, because these are messages. So let's do the weather request first. And the weather request is just the kind of data that we're going to want. And so I'm going to say, I need an integer, and this is going to be our station ID, equals 1. Now, this equals 1 is incredibly important in the definition language. This is not an initializer for a default value, and that's very much what this looks like. What this says is when you serialize this request, this is the first ordinal. This is the first object to be serialized, because what we get when we get the protobuffer information is we just get a series of bytes. And this language is saying this is how you deserialize it, because the package itself has no information about how to serialize or deserialize it. This is why it's so different from XML and JSON and other languages. We'll see it a little better here when I do the weather response. I'm going to say I need temperature equals 1. Wind speed equals 2, right? Because what I'm telling it is in what order are these fulfilled. And this is a bit about how it ends up being versioned. It isn't versioned on a versioning number. It's versioned on as this format changes, we are telling it the temperature is always at 1, or we can tell it the first ordinal is now ignored and we have this new 4th item. And so it becomes, this service becomes something that can handle different versions of the same file over time. And I'll say rain amount equals 3. So again, these numbers are all about how the serialization happens, or in what order the serialization happens. once we have that, we have the weather profile, and we want to be able to compile it so that we can then build our service to actually do something, right? Well, because we didn't start with a gRPC template, we're going to want to do a couple of things. First, we're going to need to go ahead and add to the NuGet package, and luckily NuGet is so fast these days. Oh, good, it was cached this time. And we're going to want this meta package for ASP.NET Core. What you'll see is there are packages for different languages, or that you could use this without having to have ASP.NET Core. You'll see implementation here. This is a meta package that includes all the different pieces we need. And of course, accept all licenses without reading them. And now that we have that, we can go down here into weather, and we can tell it to use the protobuf compiler instead. This is telling it that when we build this, I want you to take the proto file and generate some code that we're going to rely on. Now, because of Visual Studio being Visual Studio, we actually need to unload and reload this project for that change to take place. And I was hoping that by now it would be fixed, but it's not. So we get this weather prop, the protobuf compiler is built, and if we go ahead and try to build it, let's see where it's complaining. And you can see here, it's trying to build it, and I have obviously messed up by not putting parentheses around weather response. Let's try compiling it again, and it worked. So we now have in our project a compiled base class essentially for defining the weather service. So let's go ahead and come into here, and let's create.
I'm guessing, Shawn, like this is well documented, right? Like the fact that the 1, 2, and 3 are essentially the numbers of how it's going to be like serialized, the bytes, right?
Absolutely. In my Pluralsight course about gRPC, I talk about versioning a lot more and how you would obsolete certain members and add new members and merge new members and things like that. The protobuffer documentation is really very specific on this and talks about all the native types. We're not going to deal with a lot of types, but numbers in this example. But it supports date times and all sorts of things. And what you're really doing here in this message is defining your own type, because this could also have weather request equals 4, right? So it's not just a flat sort of hierarchy where you can only have scalar types. You can build up more complex types.
Yeah, I think you kind of answered Curious Drive's question whether can a message have nested messages, and surely you can throw objects.
Absolutely.
And other,
and you can import proto files that are just definition of types and use them in other services. It doesn't have to all be in a single proto file.
And Foolschnabel had asked this before. Does it not have decimal types? Is that
I don't remember if it does or not. I know that because these are all small values, I'm using floats, but it may. I'd have to go look at the docs to see what scalar types, because essentially there's where they're showing you the scalar types and sort of their equivalency in other languages. So now that we have this, let's go ahead and let's add there we go. Services, and then within services, I'll add our weather gRPC service, just so I can have a unique name here. And so what we're going to do is we're going to actually derive, now that we have that code generation working, from a weather service class. And you can see it's giving me weather gRPC service, But what we actually want it to do is use the using weather station. This weather station is the namespace that we told the protofile to use when generating the class. And in a weird oddity, I'm not a huge fan of this, but this is the way they worked, is the weather service actually has two nested classes, one for the client and one for the weather base. And one of the things I may have glossed over when we looked at this protofile is it said, should I create the stub classes for the client and server, for the client only, the server, or do not generate stub classes at all, just include the protofile in there. Which can be used for files that are being used by other files. So now that we have this, we can just simply override. And you can see our get weather call now has an override to where we can, okay, this is where we're going to do the work. And what's interesting is if we change the protobuf during development, this is going to break. And this is exactly what we want, right? Because the nature of the API changes. This is why the contract becomes interesting in scenarios where contracts are good, is that as the contract changes, you want the code to break. You don't want it to wait for a runtime breakage. And so we can see here we have some context call, which we're not going to use, but we have the weather request. And what we want to do is just generate, how did caps lock get up again, is generate a response, let's say. And this is going to be a new weather response. And we're just going to say response dot what? Rain amount equals, and I want these to be different so you know we're getting different values from it. So I'll create a new fake random. If you don't know what I mean by fake random, go look at go search it up. There's no such thing as really random. I'll say next double, just so we have some values there. This is the only part of this demo I hate because I always get it a little wrong. And wind speed. We won't talk about what my wife is trying to tell me. And we'll say 10. But you would actually, you know, in your IoT device, read the sensors and then send this data back. And then all we're going to do then is say return task from result and give it our response, right? Now, if this had asynchronicity to it, we could, of course, say async and not use the task from result. But because this is synchronous, we're just going to do this without actually using a wait and async. So we've defined the server, and let's make sure that it builds. And then this is where it becomes interesting, is on the client, I can now say add service reference. And one of the kinds of service references I can add now is gRPC. And I could point it at an URL where that protofile is acceptable out there. But because I'm dealing with it in the same project, and you can imagine in your own data centers, this would also be true, is I'm just going to point at that file. And because I'm adding it, it's adding all the gRPC NuGet packages it needed, as well as generating the client for us. And so here in the client, what are we going to do? Let me just check to see how we're doing in time. Okay. We're not going to get to all the demo, but the example I'll have on my website will have all the different aspects, but we'll get to as much of it as we can. So here we're going to say weather station, and remember that's the namespace. So we actually want the weather service. Bring in that namespace.
So Shawn, while you're typing, I do like the integration, like with the ASP.NET, like the tooling seems pretty polished.
Yeah, the tooling, especially in .NET 5, in .NET 3 and 3.0 and 3.1, it was a little less polished, but it still works. And I'm doing everything in Visual Studio, but if you're using Visual Studio Code, there are .NET tools that will do all the same things. So they're effectively just a spooling out into that.
And then Full Schnabel is asking if it's a source generator that's creating the C# code from the definition.
It is a source generator. Whether it's using the Roslyn source generation stuff or not, I'm not actually sure. Oh yeah, forgot it's a static. And just like the before, we have this nested type that we need to deal with. And so we're going to create, I shouldn't call it the service, I should call it the client. This new weather client. And in this case, it's expecting a channel. And what is a channel? Let's go ahead and put channel in here. Because what a channel is a gRPC channel. I think we'll need to bring in that namespace. Yep. It's not new gRPC channel. What is it? Is this the one where I go? Yeah, from address. It's going to generate a channel for us. And what are we going to put in here? We're going to put in what that server address is. And I happen to know it's localhost 5001. Now notice we're not pointing at an individual address on the server. We're actually just pointing at the server itself, because the protofile is going to know where it's located. And I'll show you what that looks like in just a minute. But in this case, we can say client get weather, and we could do get weather async as well, but I'm going to leave it at get weather for now. And I need the request, right? New weather request. If you remember, we were asking for a station ID. And because we're ignoring the station ID, it doesn't matter what we put in there, but I'm going to go ahead and do that and just tell it the request. And then I get the response. And then I can just, let's do this. Let's say console.write line response, then console.read key. And I'll just put this in a while true. And make sure that you use the while true a lot in your production code, because having unending loops is always the best policy. And so in this solution, I actually have it running both projects at once. And you'll see that the server is setting up and running, but the client is complaining, unimplemented. So we went to the server and we couldn't find it. It said bad RPC response. I know it's a little hard to see. I should have changed my defaults here to much bigger so you can see these screens. And the reason is I never told the server that I wanted to be able to serve gRPC. So let's go over to startup. And there's really two pieces here. One is to, in services, to add gRPC. So that's adding the pieces we need for gRPC. And then we need to add an endpoint for it. Add gRPC, whoops. Map gRPC service. And what is the service, of course? It's our service class, whether gRPC service or whatever you did end up calling it. And this is telling the server to add as an endpoint a gRPC endpoint for this service. And of course, you could call this for different services as well. And so let's try running it this time. And we can see we're now getting temperature and wind speed, which I evidently
there you
did.
go.
Right? And every time I press this, it's going to call again. Evidently, when I put a 0 in there, it's not going to show it because of our randomness. But we're getting the data out. So let's expand this just one more piece, and that is for streaming. That's where things get much more interesting. Let's see how are we doing on time? Yeah.
I think we got another 14 minutes or so.
Yeah, most of the boilerplate's done, so this shouldn't be that hard. So let's start with the weather. With
going back, sure. I really like how it's just like this is middle tier, like middleware for ASP.NET. You just throw in those two things, and now the server knows to serve up gRPC.
Yeah, and it's going over a web server. Like it's not a special magic binary server someplace. It's actually going over through the same thing that ASP.NET is. So it doesn't have to be this lone weird Windows service or something.
Yeah.
And you can host this just in a console app someplace. It doesn't, with Kestrel.
Two quick questions. I don't know how relevant this would be to where you're going. The generated classes, are they partial, so they're open to extension?
That's a good question because they usually don't expose themselves here. Let's look real quick because it's been a little while since I looked at the generated classes. See if I can find them again. Where did they put those? No, those are all the solutions. I'll have to remember where they generate them because I don't remember if they're partial or not.
Yeah. So Noel Stiglitz is maybe commenting on the same thing, that protocol buffer compiler generates sealed partial classes, which implement iMessage. Yeah.
Oh, so you can't derive from them, but probably you can extend them because they're partial. That makes sense.
And then all of this is happening over HTTPS, correct?
Correct.
So
HTTP 3, and more importantly,
it requires S, right? So can you add own certificates to the trust chain?
Absolutely. So one of the benefits here is that this is just using the ASP.NET Core pipeline. So you can use certificates, which normally inside of a data center is usually the most efficient. You could even use self-signing certificates in that case. You could use JSON web tokens to secure this. It's just another web request. So any security you're using for your REST calls, these would just piggyback onto, because they're going through the same authorization and authentication middleware that your REST calls or whatever else you're doing are. And that's one of the reasons I really like it is it doesn't need to have its own thing. It's just another endpoint in ASP.NET.
Yeah, roger that.
So let's take this RPC call. I made a copy of it, but I'm going to say, let's create a new one called stream. And I'm going to accept the same weather request, but instead I'm going to return a stream of weather response. And what that means is that I'm going to allow it to send weather responses as it gets those weather responses over and over and over again. Notice that this isn't anything special. It's just sort of a decorator saying this is a stream of these instead of one. And what's interesting is if we're not going to get to it, but just so you can see, the interface definition language, instead of thinking about things as like arrays, but instead of this being a stream of these, it would just be a repeat of weather response. It's a little bit more complicated than that, so I'm going to comment it out. But you can see that it has these notions of, instead of there having to be these discrete, more language-specific types, that we can think about it in this way. So let's go back to our service now that we've added, and we can just override. We could just build it first. I always forget that step. Now we can override the getWeather stream. The getWeather stream has the same request, which we're going to ignore, but now it has a response stream where we can throw in a number of these. So let's do for each. Nope. Let's do for x is less than 10 plus x. So we're going to stream 10 of our responses. So let's come up here and I'm going to do a little refactoring and say, I want a method that's called getResponse, just so we can have something that generates our response. And what are we going to do? We're going to say response stream dot write async a get response, or should have been generate response, but close enough. And let's await that. And let's add async here, since it is going to be asynchronous. And I'm using it mostly asynchronous so that I can then say task dot delay 1 second. So I can treat it like it's an actual like it's an actual stream, like that we're waiting for things to come in and then sending them out. This would actually be something more clever, but I want you to see that that when we build the client here, whoops, oh, there's one way to get it. Yeah, they are partial classes, sealed partial classes. I got there by hitting F11 going into the code. And so back here in the program, we have the same service, we have the same request, but instead of the way we're doing this, we're going to say client dot get stream. And what are we going to pass in? We're going to pass in that same request that we already created. But what we're going to get back here is, let's call it the stream. And move this up. Always remember to move it up for the people in the back of the classroom, right? As I'm going to say, while await stream dot response stream dot move next. And here I need to say cancellation token dot none. So I'm not using cancellation token, but I could. And I think I have to make this now async task. So close to being so efficient. There we go. And then what can I do? I can just say console.write line stream.response stream.current. So this will wait until that stream is closed by the server. And let's go ahead and yeah. While true. So after we go through all 5, let's just do a console read key again so that we can ask for more streams if we want to. So let's run this and see what this looks like. See if I didn't mess it up. Did I leave them open? Nope.
While it's building here, Shawn, you got me really intrigued. Like we have heard of this, that random numbers and not really random, because it kind of gets to like determinism and if it can be repeated or not.
Right.
But I started looking some things up, and it's intriguing once you get down to the math of it.
Yeah, just how computers are just unable, because they're all using some predictable seed to get it. So we can see that when we hit this, it's going to start returning. Supposed to be starting to return. Oops. I wonder why it stopped. Oh, you have to put getting the stream in the while loop. So let's try this again. So you can see we're streaming in every once in a while, 1 second apart, each of these values. And it isn't until it's done that it knows that that stream is over. So the server, in this case, this is a unidirectional, knows that it's out of data, and so it ends the stream after, what is this, 10 results. And then when we ask it again, it starts that process again. You can go ahead and do it over and over again. You can also have bidirectional, where you each have a stream, and you could be streaming from the client up to the server and the server up to the client as well. And so that relationship. And these streams are HTTP streams. These aren't some magical thing where it's trying to do things. This is actually using the standard streams that are introduced in HTTP3, and that's super important in the way this stuff works. Make sense?
This is pretty amazing. Like, you started from scratch, and you have a simple client-server response, and now you have a streaming response. It's pretty cool.
And the gRPC template that they have that you would start from if you wanted to do this is pretty easy to work with. The reason I started with an ASP.NET project is to show you that it doesn't have to be its own little silo. That if you need a gRPC, let's say for a couple of things like some IoT devices someplace, you could add it to an existing site without having to have yet another container or machine to worry about. Though there's cases for both.
Yeah. All right. So this is awesome stuff. Let me ask you a couple of basic things. So
sure.
One is, if folks want to learn more about gRPC, like what's the starting point? I mean, there's the gRPC website, but where are some things you would point to?
So luckily I have a takeaway file.
There you go.
So gRPC.io is where you would learn about it. I actually spend a lot more time when I'm working with it on the protocol buffers website from Google to make sure that I'm defining those interfaces correctly. You can see this this demo and these slides on my website later on tonight once I post them. And of course, I do have a Pluralsight course on it that if you have a Pluralsight subscription, you can just go to shawn.me/PS author, and that'll show you all my courses, and the gRPC will be in there. I go into a little bit more depth. I show how to work with different languages, how to use certificates to secure it, how to use GWT to secure it as well. So we can see more real world sort of demos of that, as well as versioning.
Yeah, very cool. And so, Shawn, let me ask you this: like, if I am a traditional ASP.NET developer, if I have built services before and I'm deploying them, and I have things behind a server farm, where are some places where you have seen like real-world uses of gRPC?
For me, the main use is within microservice architectures and communicating between servers, because you could certainly do it with REST, but having those contracts between those pieces of my system, I showed this in an earlier thing, but I think this is important to see. No, that's not it. We're almost there. I know the screen's not updating as fast as I'm hitting it. There we go. So this is pretty true to what I've used it for. I'm building whether it's inside of a Kubernetes cluster, or I'm just building different containers that I'm running on a machine or a VM or somewhere in a cloud. Being able to have these communications be incredibly quick within the data center for me is really important. But the quickness is sort of secondary. For me, having those contracts so that I can build those, and as that change happens, I can know that the other services are going to work with it in a pretty easy way, and that those are concrete contracts, so that there's no confusion about, especially in larger teams as you build things, what those expectations are. Unfortunately, even REST schemas have their limitations of how well they'll work. But inside the data center is where I've used them the most.
Makes sense. Yeah. All right. This has been really enlightening. I mean, I've learned a whole bunch about gRPC that I did not know. So
Awesome.
Thank you, Shawn.
Awesome. Any
folks,
questions before?
Yeah, that's what I was going to ask. Like, I mean, there have been chatter, but yeah, folks, any last questions for Shawn here?
And I will. I'll stop by the chat for people that are shy.
Yeah, and yeah, folks have pointed out the documentation, and like you said, like the proto buffer documentation is often the better place to start, so you're defining things right.
Yeah.
Yeah. So this is very good, very, very good.
Awesome.
Yeah.
Awesome.
Oh, and Surly Dev is asking, how's filmmaking? How did that go?
It's still going. Finishing the Hello World film was a longer process than I ever thought it would be, but it's been out for about 6 months now, available on a bunch of different streaming platforms. You can even watch it for free on Tubi, if Tubi's an ad-supported network. But if you aren't one of those people that likes to pay for movies, Tubi's a good option there. The response has been really good. I've gotten a lot out of the whole experience of sort of learning about myself while making the movie. And so I'm not quite ready to talk about what I'm filming now, but I'm in the middle of filming another film. It's not about computers or programming, though, so it's going to be a little different. But I'll certainly let people know once I release some information about that film.
That's awesome. Yeah, and for Hello World, thank you for bringing kind of our voice and how we think and the inclusivity angle to what you did. So thank you for that.
I appreciate hearing that.
Yeah, and yeah, Noel and everybody thinks that was a great job, great talk. So thank you so much, Shawn.
Thank you.
Yeah. All right, folks. In the chat room on Twitch, thank you for hanging out with us. Thank you for your questions, and yeah, above all, thank you, Shawn, for giving us an hour of your time and educating us. If you are a part of the user group, or if you came in through Meetup and you have signed up, there's a Teams link, which we're going to hop on there just to kind of hang out offline if you may. So thank you so much for being online with us, and we shall see you on the next stream. And yeah, thank you, Shawn.
Thank you.
Yeah. Bye for now. Have a great day.